The number of Wi-Fi devices in homes is constantly increasing, and more devices are running high bandwidth and real-time applications like video streaming and online gaming. A home is becoming a mini enterprise and pushing the performance limits of an average residential access point. Due to the increasing importance of the quality of the Wi-Fi in home, consumers are willing to pay several hundreds of dollars to get good Wi-Fi in the house, and service providers are starting to do extensive testing before deployments in order to meet the high quality expectations and to avoid expensive on-site customer support and truck rolls. Although the Wi-Fi Alliance does a very good job of certifying interoperability of access points, there is still a strong need in the industry for a residential Wi-Fi performance test plan. The Broadband Forum has identified this need and created the TR398 test plan that focuses on Wi-Fi performance testing of 11AC residential and small office Wi-Fi access points. In our opinion, with this test plan, the Broadband Forum has done an excellent job in striking the right balance between bringing all the advantages of controlled, conducted, and automated lab testing procedures and correlating that with the real use cases that are seen in homes. The test plan covers several different areas of Wi-Fi AP performance that can be mapped directly to real-world usage scenarios and also defines very clear pass-fail criteria. At Candela Technologies, from our many years of experience in Wi-Fi testing and after studying this test plan in detail, we believe that any access point that passes all these tests has a very good chance of providing an excellent overall Wi-Fi experience to customers when deployed. This test plan covers 6 main areas that are all very important for good Wi-Fi experience: RF performance, coverage, capacity, stability, tolerance to interference, and bandwidth management. Under these 6 areas, we have a total of 11 tests defined by the test plan. The foundation for any well-performing access point is a good radio receiver. In the real world, the AP has to handle many different types of clients at many different distances, transmitting at many different physical layer data rates and transmit power values. On top of that, all these clients can be at different antenna orientations with respect to the AP's receiver. The AP's receiver should be able to handle all these scenarios and still receive and decode all these signals well to be able to successfully communicate with clients and achieve good throughput. The receiver sensitivity test is designed to test the AP's receiver at different combinations of modulation and coding rates, different signal power, and different antenna orientations. With the advent of wireless TVs, phones, tablets, wireless cameras, gaming systems, doorbells, thermostats, digital assistants, and a number of other home automation devices, it is becoming common to have 30+ Wi-Fi devices in homes. The maximum connection test is designed to test the ability of APs to support several Wi-Fi clients simultaneously and deliver consistent throughput to all the clients. Gone are the days of $50 cheap residential APs with weak CPUs and minimal system resources. Those cheap APs cannot meet the ever-increasing Wi-Fi performance demands in a home. A modern residential AP is expected to get close to theoretical maximum possible performance, at least in ideal conditions. The maximum throughput test is designed to test and make sure the AP can achieve a certain minimum amount of throughput both upstream and downstream on both the 2.4 and 5 GHz bands. Your doorbell may be a 11B client, and your TV may be a 11AC client, and your thermostat may be a 11N client. It's very common to have many different types of clients using the latest and also the legacy Wi-Fi standards. The clients using legacy Wi-Fi standards will typically take up much higher amount of airtime to send and receive a small amount of data because they transmit and receive at lower physical layer data rates. It's the job of the AP to make sure it can service all these different types of stations and share the airtime fairly. The airtime fairness test is designed to test this aspect of AP performance. With that new sprinkler system in the backyard, the surveillance camera in the patio, and the new garage door opener in the garage, Wi-Fi is expected to work at all corners of the house. The rate versus range test is designed to test the coverage aspect of the access point. The spatial consistency test is designed to make sure that an AP's antennas, transmitter and receiver are designed in such a way that it can perform well at various signal strengths and antenna orientations relative to the receiver. It's very common to have a TV in the upstairs bedroom, the computer in the downstairs office, the tablet in the kids' room, all using Wi-Fi all at the same time. A multiple station performance test is designed to test the ability of the AP to handle multiple clients that are at different distances from the access point. Several clients can connect and disconnect with the AP at all the time. The AP is expected to handle all the state with these clients while delivering good throughput to other clients that are currently connected to the internet. The multiple association disassociation test is designed to test this aspect of AP performance. You're deploying the latest and greatest 4x4 MIMO AP, but the deployment has a bunch of portable Wi-Fi devices that only support 1x1 or 2x2 MIMO. Then the user will never get to enjoy the full power of the 4x4 MIMO AP unless the AP and the stations support the MU-MIMO feature. Does your AP support the MU-MIMO feature? Well, you can find out by running the downlink MU-MIMO performance test. It's the weekend and everyone in the house is binge watching their favorite TV programs in their rooms all day and all night. Can your Wi-Fi hold up, or will your AP crash and burn? Run the long-term stability test to find out. You're deploying Wi-Fi in a busy apartment complex with hundreds of Wi-Fi networks around. Will the AP's performance suck when it cannot find a clear Wi-Fi channel? The AP coexistence test is designed to test this aspect of AP performance. All in all, this test plan does a very good job of covering various aspects of AP performance. If an AP can do well on all these tests, then the folks deploying these APs can go in with a high degree of confidence that these APs will work well when installed. Candela Technologies now offers a single push-button, fully automated TR398 test system, including all the necessary test hardware and software at very affordable prices for everyone in the Wi-Fi ecosystem to use. The ROI is very simple. You can put two of your highly paid and very talented engineers on developing this test system, piecing together the various building blocks, writing automation scripts, in some cases manually running all the tests, or just simply take advantage of all that work we've already done for you and save a lot of time and money and substantially speeding up your test cycles. The TR398 Testbed Building Blocks should include a multi-station emulator that can emulate at least 32 realistic Wi-Fi clients, a traffic generator to emulate the different traffic patterns that are called for in the test plan, programmable attenuators to simulate distance for the receiver sensitivity, rate versus range, and multiple station performance tests, an AP emulator to emulate alien APs for the AP coexistence test, RF enclosures for the test equipment, and a large RF enclosure with a programmable turntable for the AP under test, RF cables, RF splitters and combiners, and automation test software that can control all these components and run the tests. Here is a diagram of the Candela TR398 testbed. The testbed includes a Candela LAN forged chassis with 3 11AC 2.4 GHz radios and 3 5 GHz 11AC radios and 2 gigabit Ethernet ports. Each radio can emulate 64 stations for a total of 384 stations across the 6 radios. The LAN 4 chassis also has a built-in traffic generator, and the traffic can go to and from the Wi-Fi stations through the AP, out of the LAN interface of the AP under test, and back to the LAN4j Ethernet port, allowing the LAN4j system to source and sync all the traffic and make all the end-to-end performance measurements. The 6 radios are used for various functions like station emulation, AP emulation, and MU-MIMO and other tests specified in the test plan. The testbed also has 6 programmable attenuator ports used to set up a 2x2 MIMO test configuration between the 2 chambers. This is a picture of the actual testbed that I'm using in this demonstration. As you can see, this setup has all the building blocks needed to fully automate the TR-398 testing. The user interface for this test has a single screen where the user can select the DUT and connect to all the testbed components and select the test to run. I'll go through this in more detail in the demo. One of the really awesome parts of this product is the test report that is made available at the end of the test in HTML and PDF formats. So this is the actual TR-398 test setup. The test setup has 3 main parts to it: the tester chamber that has the LAN4j test system, the programmable attenuators, and then the device under test chamber that has the device under test. So first let's look at the tester chamber. Inside the tester chamber, we have the LAN4j test system that is used for running all the TR-398 tests. So if you look at this system has 6 radios in it. Now all these radios are 4x4 MIMO 11AC Wave 2 radios, and they're all completely cabled. The first 4 SMA ports here are a 5 GHz radio, and the second 4 SMA ports are a 2.4 GHz radio. Similarly, we have 6 total radios in the system, and each radio is a 4x4 MIMO. So 3 radios are 5 GHz and 3 radios are 2.4 GHz. All 6 radios are needed to run the entire 398 test setup. So the first 2 radios are used for most of the tests, and tests like throughput test, client capacity test, and things like that can be run with just 2 radios. But then the remaining radios are needed for running more advanced tests like multi-user MIMO test and tests where we need multiple clients at different distances from the AP. So we'll need multiple radios for that, and each radio will go through a different programmable attenuator simulating different distances from the access point. We also need the remaining radios for the AP coexistence test, where the other radios can act like alien APs talking to alien stations that are also in the same condition domain as the device in a test for doing co-channel and adjacent channel interference tests. The way we have cabled this is we have taken the each set of 2.4 and 5 GHz radios and put them through combiners and then connected to the chamber here. And from outside the chamber, these connectors, these SMA ports go to the programmable attenuators that are right here. These programmable attenuators have a 0 to 95 dB range at 0.5 dB steps that are programmably controlled from the test system. So you can see that in front of the programmable attenuator, we have these USB cables, and these USB cables are connected to the back of this chamber, and then from inside the chamber, we have them connected to the test system here, and that is how the LAN4j system controls these programmable attenuators as a part of the test. So now let us look at the device under test chamber. The device under test chamber is a much bigger chamber here because we need the turntable in this particular setup. So this is when you open the door on this chamber, you'll see it has a lot of components required for this test. So this is basically, you can see that there is a device under test on the turntable. This is a 2D turntable, and all the connectors from the programmable attenuators come into the chamber through these connectors, and the antennas can be connected to an antenna mount, and then the device under test is over the air inside the chamber. This chamber comes with an extensive set of features. You can see that there are several USB ports, 4K HDMI ports. These USB ports, these Ethernet ports are 10 gig Ethernet ports. We have multiple Ethernet USB ports. There is a webcam, there are antenna mounts, There is LED lighting inside the chamber, and there's also excellent absorption. You can see the absorption material that's inside the chamber here. It also has a universal power strip to connect it's a universal power outlet to connect basically access points from different countries, and it also has other really cool interfaces, like there is a fiber interface, there is a coax interface, and this chamber also comes with a display that shows the IP address of the chamber guard and the position of the turntable to manually control the turntable. But then there is an Ethernet interface on the back of the chamber that is connected to the network, and using that Ethernet interface through the API, the LAN4 system can control the turntable for this particular testbed. So now we come to the LAN4 user interface to actually start running a test. So when we go to the LAN4 UI and open up the LAN4 manager, under the port manager tab, we will see all the physical interfaces that we talked about in the testbed. So this LAN4 system, as we spoke before, has 6 Wi-Fi radios that are used in the test. You can see them from Wi-Fi 0 to Wi-Fi 5. And then there are 2 Ethernet ports. Ethernet 0 is used for managing the system and controlling it from the user interface. And then Ethernet 1 is my upstream port, which is connected to the LAN interface of the access point. So when we generate traffic from the wireless interface, from the Wi-Fi clients through the AP, and then the traffic would go out of the LAN interface to the access point and get to the Ethernet 1 port on the same LAN4 system. So the LAN4 system is used for both sourcing and syncing the traffic and making end-to-end measurements. So now to actually run a test, we need to click on this chamber view button that opens up a graphical view of the test that we're going to run. So as we showed in the previous segment of the video, there are 2 chambers. There is the tester chamber that has the LAN4 system, and then we have the device under test chamber that has the device under test. Now the user can go and create all these chambers and the LAN4 systems and the connection between the chambers and the device under test chamber, and add a device under test itself through this UI through various configuration steps. We do have a separate video on how to actually create this test scenario and add all these things to the canvas here on the chamber view. Posting the links to that particular video in the description section. Now to run the test, I'm going to select the TR398 test and click on the run test button. Once I click on the run test button, it opens up this section of the UI, which is a single screen where we can configure the entire TR398 automation test and run all the tests. Now there is also a webcam, as I mentioned, inside the chamber, so we can use a simple program to actually view what's happening inside the chamber in real time while this test is being run. So for this particular section of the UI, we're going to select the 2 radio interfaces of the device under test. We're going to select the 6 radios that are going to be used in 3 groups for this particular test. There is also a calibration step where the user needs to enter the device under test RSSI on the 2.4 GHz radio and the 5 GHz radio at 0 dB attenuation on the programmable attenuator. Now the user can also select the attenuator modules that are used that are connected to each one of these radios. Based on the serial number of the attenuator modules, those things can be selected here. The device in a test chamber is also selected, and the upstream port, the Ethernet port where the traffic is sourced and synced on the Ethernet side, is also selected here. Now the most important part of this particular page is to select the test that you want to run in an automated fashion. And now we can select these are the 11 tests that are part of TR398, and based on which tests you select, there is an indication of the estimated test duration. So let's look at a time lapse of a 6-hour test condensed to 3 minutes. So once the test is completed, the system generates HTML and PDF reports of the entire test run. So this is an example PDF report of an overnight test that I ran yesterday night. So in this PDF report, you can see the timestamp of when the test was run. It provides information about the device in the test, model number, SSID, BSSID information, the person who ran the test, the estimated runtime, and the actual runtime of this particular test. The test report starts off with the objective of TR398 in general, and then there is a summary table that shows the result, the pass or a fail at a test level for all the 11 tests that have been run. For the test that failed, some summary information is provided of why that particular test failed. So as we scroll down in the report, a lot more details are provided in this test report. You can see that this report is 37 pages long. So the first test that was run was receiver sensitivity test. There is information about the summary of the test, the test procedure, the pass-fail criteria. All of this information was taken directly from the TR398 spec. As we can see, the receiver sensitivity test needs to be run according to the spec at two different MCS rates, 0 and 7 in the 2.4 GHz band at 20 MHz channel bandwidth, and then at two MCS rates, MCS 0 and MCS 9 at 80 MHz channel bandwidth in the 5 GHz band. And so for each one of these steps, there are a lot of sub-steps where the tester needs to go through different program attenuator values and different antenna orientations values. And so there are lots of steps that are run for this particular test. The receiver sensitivity test itself takes around 3 hours to run, and the pass-fail results for each individual sub-step are actually provided here. This is the expected result, and this is the achieved result for each one of these sub-steps here. So we also show a real-time throughput of that particular entire receiver sensitivity test. As we scroll down in the report, we'll go through all the tests here. Again, there is a maximum client connection or maximum connection test that runs with 32 stations. There's a summary test procedure and the pass-fail for each one of the individual steps in that particular test. And as we scroll down, the same is repeated for all the tests, and the results for all the different tests are provided in this particular PDF report. So one of the things that we observed as we ran these tests is it is actually quite hard to pass this particular test and pass all the test runs, but it's not impossible. We can have APs actually pass all these tests, or at least most of these tests. One of the things that is very important is proper calibration of the test bed, because several tests are dependent upon the receiver sensitivity of the receiver and the amount of attenuation and path loss we have within the entire test bed. So proper calibration is important. And one of the other things we noticed is even if one of the steps fail in this particular test, for example, some of these tests could have literally hundreds of sub steps, and even if one of those steps fail, the test is currently considered as fail, which means that it is going to be a little bit hard to pass some of these tests. One of the things that we are adding here is if a specific test step fails, we will rerun that step a couple of times to make sure the failure is repeated and it's not a one-off failure. So if you're interested in getting your hands on one of these systems, here is the exact bill of materials used in this test bed. And the nice thing is that we can provide all of this in a single purchase. Most items can be shipped almost immediately after receiving the purchase order, but some items like RF chambers may have up to 4 weeks of lead time. Here are some high-level specs on the various components. Our chambers, as I mentioned before, come with excellent isolation, several different types of interfaces including SMA, USB, 10 gig Ethernet, fiber, coax, 4K HDMI, DC power, and universal AC power outlets inside the chamber, webcam, LED lighting, 2D turntable, and much more. More detailed specs of all the hardware components are available on our website. If you're interested in knowing more about pricing, here is a rough estimate of the pricing. The system prices include the hardware, software, and 1-year warranty for both the hardware and the software. Please contact us at sales@candelatech.com if you'd like to see a live demo or have any questions about this test system. Thank you.